October is Bat Appreciation Month, probably most likely because of Halloween. There is a lot of fears around bats. Hopefully nobody in here is afraid of bats, but if you are, maybe I can help teach you some things about bats. And you know what? They're actually pretty cool. And there's a lot of myths around bats. Some of them, people obviously can tell that, hey, that's a myth, probably not true, but bats are blind. The saying, oh, you're blind as a bat. Aaron over there is probably blind as a bat. But bats actually have a great vision, and they're excellent flyers. But bats here use echolocation to see at night. Echolocation is not exclusive to bats. Marine mammals use them, and even shrews. Not all species of shrews, but some underneath ground. And these bats are flying around at night. They're flying really fast, and they're hunting tiny, tiny prey. So they use this sonar, and it's actually really, really loud. If we could hear it, they're out there screaming at night. But most bat echolocation is at a higher frequency than we can hear. But some of the bigger-bodied bats, like the hoary bats and the Florida bonneted bats, have a lower frequency that we can hear unless you damage your ears. I've actually walked around Jackson and heard hoary bats in the pine forest. I was like, is that a bat? Oh, yeah, that's a bat. But most of the ones I work with never could hear. But these bats, they emit this sound, and it feeds back off of insects or trees or buildings and lets them know where they can fly and where their prey is. So like I said, most bats are screaming, but moths are actually quite intelligent, and they have found a way to not be dinner. They can actually detect bat echolocation calls, and some have developed ways of deflecting those calls. So the sonar comes off and they deflect it away, or they can even dampen it. So Raffinus bigear bats, they almost exclusively eat moths. So you got to be a little bit smarter than your prey. So they're actually quiet. When they go away from all the other bats and they emit their call, it's actually quiet. So that echo, as you know, your echo is a little bit quieter than what you scream out. So that echo is going to be even quieter. And that's why they have such huge ears. Their ears are about 1 inch long, so they can help hear that. But yeah, they almost exclusively eat on moths, so they need to find a way to be able to catch the moth. Bats are the only mammal capable of true flight. That is true. That's not a myth. That is true. Here in Mississippi, we have the southern flying squirrel. They're just bat wannabes. They do have that extension of the skin called the patagium from the wrist to the ankle, but they just kind of fall. They're more like a kite where they can catch wind and help direct, but they cannot actually generate lift. So some of our bats are really exceptional flyers, superheroes. They got long tapered wings. This is a Mexican free-tailed bat. These guys can fly up to 100 miles per hour. So that's like driving down the interstate really recklessly, right? So they really got to make sure their echolocation's really good. Or actually, these guys can fly up to 10,000 feet in the air to intersect, especially a lot of migratory pest insects, pests to our crops. So superhero out there, saving farmers lots of money from crop damage and not having to use insecticides. Bats get tangled in your hair. I have a lot of hair, guys, and normally it's really curly. And I've been in tiny crawl spaces with thousands of bats. Never got a bat stuck in my hair. So obviously, if it didn't happen to me, it's not real. But this conception is based off of you're out at night and you see a bat swoop above your head. It's not going towards your hair. There's just a bug above your head. And thank you to that bat because it probably was a mosquito and therefore you didn't get bit. Bats are flying mice. This one's really old. In fact, there's some languages around the world where their word for bat is based off of flying mouse. But bats are actually in the order Chiroptera, and they're more closely related to primates than they are to rodents. But since they're small, they have tails, sometimes their ears look like mice, they often get confused. But a mouse, has a very short life, about 1 to 3 years. Our bats can live anywhere from 10, 15 years. The bigger bats can live up to 30 years. So completely different life expectancies. Mice, they often reproduce often and they have lots of babies. Our bats are only reproducing once a year and they usually have 1 to a handful of pups. So bats are part of the order Chiroptera. That is Latin for hand wing. So if you look at the bat's arm, this is its fingers right here. And that's what the wing is stretched through, down to the ankle and then even on to the tail. So literally the order Chiroptera is hand wing. They use their thumbs to climb. So they like to show off that they can climb with just their thumbs. They also like to hang by one toe. Pretty exceptional. So bats are then further classified into mega and micro bats, yin and yang. So all our bats here are micro, they're tiny. All our bats use echolocation. All ours have tails. There are some micro bats that don't have tails, but none of them are here. Mega bats are what usually, if you're watching Facebook and you see a cute bat eating a banana or whatnot, those are the mega bats, usually the ones out in Australia or in the tropical regions. They're big, they never have tails, they use their vision to see their surroundings, to find fruit and whatnot, and they do not use echolocation. So bats are found around the world except for extreme polar regions and in extreme deserts. There's no food for them there, therefore the bat's not going to be there. There's over 1,467 bats known in the world right now, and there's still new species being described. They're their second most specious mammal order after mice. All the rodents, there's about over 2,000 of them, but there's a lot of diversity. A lot of variation in size. So the smallest one here, the kitty hognose bat, that's about 2 grams. It's also called the bumblebee bat because it's so small. But literally, if I put this on my finger, that's even too big. It's this big. And there's found only a small area. And then one of the biggest bats, there's several flying fox species that are pretty huge. Covering my notes. That's about 1.4 kilograms or about 3 pounds. And that, if you look closely, that's its baby right there, hanging on. So Stella Luna, if you ever read the book Stella Luna, that was a fruit bat. Our bats do carry their young on them, but not often. So in Mississippi, our smallest bat is the tricolor bat. They're about 4 to 6 grams. I work with them a lot. They're the ones I call the flying chicken nuggets because of their size and color of a McDonald's chicken nugget.
Way to show them some love.
Yeah.
For the foxes.
Yes. One of our biggest bat is the hoary bat, and they're huge because they're very migratory. They can get up to 38 grams, especially when they're packing on weight right before winter. This is the only bat species that ranges across the continental U.S. and even Hawaii. So it's in 49 out of our 50 states. They do not get into Alaska. So only bat of Hawaii, and they've actually been so far removed from the continent, those bats there, that they're actually their own species now, the Hawaiian hoary bat. But these are the ones I call the George Clooney of the bat world because they got that nice touch of gray. So their name, hoary bat, comes from hoarfrost and makes them look like they're nice and frosted. I don't expect you to read this. I just wanted to emphasize that we have 14 species of bats. Most of them are in the Vespertilionidae, which is evening bats, and then the Molossidea, which is the free-tailed bats. Only 5 are considered common in Mississippi. The free-tailed bat, big brown, and evening bats are ones that you're most likely to find if you have a bat in your house or like in your attic or porch columns or even shutters and whatnot, and they're the ones that are going to use bat houses. So bat houses best benefit common bats. And then eastern reds and seminoles are found commonly around trees around your yard and through the forest. They're strictly tree bat. And then the rest are species of greatest conservation need. So southeastern myotis, northern long-eared bat, gray bat, and Indiana bat are all in this myotis group, and they all look very identical to to distinguish them, you kind of have to, there's various things, but a lot of it really needs you looking at the foot. So I have looked at a lot of bat feet. Southeastern Mammalogist are pretty common in the state now. Still a species of greatest conservation need because they really rely on bottomland hardwoods, which is the area that needs a lot of protection. It's easily wiped out. The rest of these guys are only here that we know of in the summer. We're still learning a lot more. Last year, we found over 40 new individuals of northern long-eared bats. Sites that we surveyed in the winter, but then we went back in the summer, and lo and behold, the bat that's federally endangered has been hanging out in Mississippi, and we just didn't know. This species was recently added to the list because it was super common. Like, this was one of the most common bats in, say, like Kentucky and northern areas, but white-nose has drastically decimated them. They've lost over 99% of their population in such a short period of time. But I'll get into white-nose in a minute. But just wanted you to know that's one of the species that's been most affected by it. Indiana bat has been on the federal endangered list since 1966. It's been on there a long time. That's about when the list, the Endangered Species Act was first issued. Gray bat's been on there since 1976, and they've been rebounding. We're actually looking at delisting the species. It's actually quite rebounded its numbers. Its caves are being protected, a lot of gating. So hopefully in the near future, Fish and Wildlife will actually either remove endangered from it to downgrade it to threatened or completely remove it from the list. So that is a little bit of good news. These are all our tree bats, our lazuarans, our hairy-tailed bats. So most of our other bats do not have hair on their tails or on their side of the wings, but these guys do because they mimic, like this one right here is a Seminole bat. It mimics a pine cone. When it hangs in trees, it's really trying to look like a pine cone. Some of these are trying to look like dried leaves. They'll hang out in Spanish moss, but they need that hair on their tails to keep them warm because they're not going under subterranean structures. What these bats do is they tuck those wings in, and they'll use that hairy tail and wrap them up like a blanket. So they're just flying around with their own blanket. And this is our rest of our bats. So again, the little tricolored bat and a Raffinus big-eared. And these two are super common, the free-tail, big brown. Evenings and free-tail look a lot alike, just one significantly bigger. And then the silver-haired bat is only here in the wintertime. And unlike us, that get grayer as we age, these guys actually lose their gray as they age. So right now, we're in fall swarming. That means bats are moving from where they were in the summer to try to find where they need to be in the winter. And this is usually where moms are taking their young and be like, this could be a nice place for you to stay in the winter away from me. Or here, it's time for you to move away. Sorry, bye-bye. But then they go into winter. It starts at the end of October when we get that first cold front, but we really don't see peak usage of our winter sites until about December, January. Our bats here go into torpor for which is a short period of hibernation. So torpor can be like literally they're dropping their body temperature for a day or several days. Up north, that can be a little bit longer. Our coastal areas don't get as cold, so they don't go into that deep torpor, and they're actually considered year-round active. But once it warms up, sometimes we get a warmer year and they'll move out in February. Sometimes it lingers, depending if we had a cold front or even an ice storm. And then they'll move out, and spring migration is pretty short because those females are now pregnant and they got to find somewhere pretty quick to have their pups. And then in the summertime, the females go off alone and the males will go form bachelor colonies or live the good life for the summer, while the females will congregate together and have their pups. So this photo, those tiny little splotches of different colors, that's all individual bats. There's over 2,000 bats in here. And these are southeastern myotis, and they'll leave their pups in here while they go fly at night, and they'll come back and they can recognize their individual by sound and smell. So they're pretty good at that. And then this is 4 eastern red pups. So it's pretty common in the summer with red bats especially because they have so many pups where the mom gets exhausted and she just lands on the ground and she can't really get back up. And so sometimes they come here, sometimes we can find a wildlife rehabber that helps mom out by taking care of her young so she can rest. So last year, we had our first ever State of the Bats report. And this was a big group effort from hundreds of bat researchers around North America. And it's something that we had been in works for a long time because we've known that there's been a lot of threats that bats are facing. And they found that 52% of bat species across the continent were at risk of severe decline in the next 15 years. So in the United States, we have 44 species here. That's only 3 that are actually considered secure, that are in such a great shape that there's threats to them are minimal. And there's 8 apparent secure in the lighter blue. 26 are vulnerable, so something is happening to them, and we could put conservation towards them to make them more secure, and then 7 are imperiled. So just like any wildlife, most of 98% of bat species are losing habitat. Here in Mississippi, it's fire and suppression, and then degradation and destruction of their roost and foraging areas. So that's where, our land managers come in handy, and they help us manage the lands for bats, not just other game species, and help by keeping contiguous forests and not just cutting them down for yet another shopping center or whatnot. But this is really helpful to really focus our efforts on what is threatening our bats and how can we help them. Next thing is 82% of species are at risk from climate change over the next 15 years. Last year, we had a really pretty severe drought, and we saw several more bats dead in our winter hibernaculus than we normally do. We usually get like 1 or 2 for unknown reasons, didn't make it, but for this one, they were in poor body condition by the time they needed to go in torpor. They're a lot thinner, and there wasn't enough water on the landscape for them to drink. The heat waves and severe winter storms, so we always have heat waves. It's Mississippi, we always have heat waves. In the summer across the U.S., we had a lot of states reported a lot of deaths in big brown bats and evening bats, and we saw a lot of evening bat deaths here because the heat was getting to them, because they were picking houses to roost in instead of forest, and the houses weren't shaded, so then you had all the heat plus the sun on them, and it wasn't good. And then winter storms. Several years ago, we had that big ice storm, especially the one that hit Texas that knocked out the wind turbines. I know that's more because that's when hundreds and thousands of free-tailed bats ended up dying. They were using bridge structures down there, and the biologists went down there to try to remove the bats, and several were found dead on the spot. And they tried keeping them for a few days, and they just didn't recover. They don't handle cold very well as the free-tailed bats. They're more of a tropical species, so when you had something extreme like that happen, it can wipe out several individuals and several thousands of individuals, and it takes a long time for especially species that only reproduces once a year to recover from events like that. And then 45 species are threatened by energy production. In Mississippi, we originally weren't supposed to have any wind energy, but increased technology has changed that. We have our first wind farm, and it's going to keep increasing. We're going to keep seeing new wind farms, especially off our coast. And roughly about 500,000 bats are killed each year, especially during fall swarming, migrating through. But there's ways so we can mitigate that. Bats only fly on low wind nights. Wind turbines don't really get much energy on low wind nights. So if you just do a curtailment, working with these facilities is like, hey, if you just don't operate during these low wind nights, then you don't really have much of an impact, except for the bats that are unfortunate to collide with the actual tower. But there's something to the smooth surface where sometimes the bats actually can't perceive it. But these are impacting mostly 4 bat species that are actually super common right now. And it's projected for them to lose more than half their population in the next 15 years. So what was common, and we were like, okay, great, they're doing their thing, it's fine. Now we're having more species that could be impacted and more conservation effort that needs to go into them. Horia bat is the poster child for what's been affected by, what bat species has been affected by wind turbines. White nose syndrome, Aaron mentioned this. This is how I started here at the museum. I first started as a technician and going into caves and culverts and whatnot, crawling around and collecting swabs. And I'm now the state lead for monitoring the spread of this fungus around the state. So how many have not heard of white nose syndrome? Okay, good. That makes me feel really great. Most of the time I get everybody raising their hand. I'm like, but have you heard of chronic wasting disease? Just making a little pig. I used to work with deer too. So white nose syndrome is caused by, and I'm only going to pronounce this once, Pseudogymnoascus destructans. I'm going to call it PD for short, so PD. It is a fungus. It's not native from here. It's invasive. It was first documented in New York in 2006, and it has wiped out millions of bats. And it has spread from, New York, and tiny little cave there, and it has gone through all the United States and into Canada. It has yet to have been detected in Mexico. And it has sent the northern long-eared bat to the Endangered Species Act. Tricolor is currently proposed to be listed, and Fish and Wildlife is evaluating little brown bat. And up here, this is northern part of Arkansas. I was talking with the Arkansas biologist about his little brown bats. And he said he used to have thousands of them, and then white nose hit the state. And the last time he saw one was literally one individual in 2020. That's how much this is wiping out areas that used to have thousands of bats to nothing. So that can have a detrimental effect on, one, now you're losing all your pest control. Bats aren't there to eat all the insects. Some of these insects are agricultural pests. Some of these have a lot of bloodborne diseases that they can pass to humans. So you really need your bats. In Mississippi, we started doing surveillance in 2013-2014 winter, and we did find the fungus. So you can have the fungus in an environment, just like if you swab your skin, there's probably things that are on there that you probably don't want, but you don't have an active infection. So we found the fungus in several environments, and that's all we were finding for several years. We're taking swabs, we send it off for DNA analysis, and they say, yep, the fungus is here. But we never actually saw an active case of white nose syndrome until 2020. White nose syndrome is called that because the fungus, when it actually is visible, it manifests on their exposed skin and creates a white nose, and grows on their ears and on their wings and on their tail. So this was a culvert in Montgomery County, and it was just one individual, and it was a deep crevice. And this was the first time white nose syndrome has actually been documented in a culvert. We thought our culverts wouldn't actually provide enough of the cold and right environment for this fungus to grow. But Georgia saw it the same year too, another case with a culvert and a deep crevice. Then in 2023, neither one of us saw anything. So we're like, okay, maybe it was just a one-time thing. And then this past winter, we had 3 individuals, same crevice, whatnot, but our bat numbers are still increasing. So we haven't seen a detrimental effect of the fungus here, but it is something that we are keeping a close eye on. And what this fungus does when it invades their skin, so this is only during the winter time when they're supposed to be in torpor and they're supposed to be sleeping, and it's irritating them. It's making them wake up more. So they're going through their fat reserves, they're going through their water reserves. And up north, they can't really go fly out to drink water because maybe everything's frozen, maybe the bugs aren't so active. But down here in Mississippi, we never really have that problem. In fact, a lot of our caves already have, if you go into them, you think the mosquitoes die in the winter. No, they actually go into our caves. So our walls are covered with them, and actually you even see a mosquito on a bat. So it's like, who eats who going on there. But yeah, so this fungus invades their skin, irritates them, makes them wake up more. Eventually, the fungus will start erode their skin and their wings and make them incapable of flying. And then they eventually just starve to death. And it can happen within 40 days from infection to death. So, down here our winters are pretty short, but up north where it can take up several months, that's why it's causing a lot of mass mortality. So out of the 44 species in the U.S., 12 have actually been able to grow this fungus on them. These are all going to be the bats that actually are using your subterranean structures like your caves, your mines, and your culverts. So tree bats, not so much. The ones that are highlighted are the ones that occur in Mississippi, but the gray bat, Indiana, and northern, we only have them in the summer months, so we don't have any of those here in the winter. Tricolor bat's the only one that we've seen with actual white nose on them, but we have detected the fungus on our big browns. And then over here, these are 8 species that have been swabbed and tested and that can have the fungus on them, but they actually don't have the active disease. And so what they're doing is essentially helping the spread of this fungus, because this fungus can spread from bat to bat, bat to environment, or environment back to bat, as well as humans. When we go into, say you're going to a toy cave, or like us researchers, when we go in, and you can actually get the fungus on your clothes, and if you don't decontaminate or wash your stuff, and you go to another site, you can spread it around like that. But this fungus does not affect people, it just can be spread by people. And this is what it looks like under UV light. It kind of looks like a pollen or Cheeto dust, depending on how hungry I am or if my allergies are messing up. But UV is not actually that accurate a way to say if the fungus is there. That's why we have to do swabs and send it off to a lab to get DNA analysis. So just with like any disease, you have your host, susceptible host, you have your pathogen, and conducive environment. So there's ways to mitigate the effects of white nose. There's no cure, but you can, there's chemicals that you can put into the environment, fungicides, that can kill off the fungus. But you don't want to do that in a cave because there's actually natural fungus there that you don't want to kill off. But a culvert, sure, that's artificial habitat. I will gladly go put this in there. But this only is effective for a few years, and eventually the fungus is still prevalent. So what it does is allows the bats to get exposed to the fungus at a low dosage so they can actually develop a natural immunity. We have been seeing that going on. So that's the goal of our wildlife population, is for them to actually develop a natural immunity. There are some places, I think Washington is doing vaccinations, but then you gotta hold one bat and give them a vaccination. And then you don't know if you need to do it again the next year or if it's passing along to their young or anything like that. So that's time consuming and expensive, and you don't know really what the ill effect of that is. And then there's habitat modification. So this is a cold-loving fungus. So maybe you can alter the cave where it's a little bit warmer in there, but then you might make it where then the bat doesn't want to actually roost in that cave. So there's issues with that. And UV light. This fungus only grows cold and dark environments. It has never developed a resistance to UV light. So just a little bit of sunlight can kill this fungus, or just a UV light. And sometimes biologists will actually go and put UV light, and they have to do a battery source or power source into the cave. But the problem is UV can actually destroy your eyes and can destroy bats too. So cost and effect, what will work, and there's a lot to go into it. But trying to save the bats so they're actually still here to develop a resistance to this fungus is key. And there's about a white nose coordinator in every single state, and we talk to each other every 2 weeks and trying to figure out what to do and how we can work with each other to better solve all our questions about this fungus and to stop the spread. So outside of white nose, I do a lot of other bat surveys. So of course I do go into the caves and culverts in the winter, sometimes the summer. Survey bridges. There's a few bridges that do have bats, whether underneath there. But in Mississippi, we have this unique structure called a debris deflector. where it's actually open column, and it's really like a tree cavity. And so all of our bottomland hardwood species will actually use that too. So that's really cool. So that's a way for them to have artificial roosts when their habitat might be altered. And I will go into an abandoned building if you tell me there's bats in there, okay? I will do it. I've seen some creepy, creepy things, but I've also seen bats, and it is well worth it. And I have done some bat house surveys and built bat houses. I'll get to your question later. And do acoustic surveys. So like I said, the echolocation. Well, you can actually ID a bat by its echolocation to some degree. So different body sizes will emit a different call. Bigger body bats are going to have your deeper call. Your little guys are going to do the higher pitched calls. I'm not going to go into the physics of sound and all that, but just know we can ID them based off of their call. And what's super cool, so this is all the same bat. That's how loud it is. That's a oscillogram. So this bat was kind of a little bit farther away from the mic. That's it in full spectrum, so you can actually see it's emitting in a harmonic, so an octave above. And then this is called zero crossing, where it's just these bottom line turned into dots. And what you can see, so this is a bat calling, and then it found something really cool, so it got really excited, so it's doing multiple high frequencies. And then you see that little cluster right there? That's it munching on a bug. So 1 bug, 2 bug, 3 bug, 4, you can count how many feeding buzzes until, and this is all like, if I had a timestamp, it was like, this is a 1/10 of a second going, 1/10 of a second, 1/10 of a second, 1/10 of a second. So this is happening really fast. So, their brain's working that fast, they're munching, they're going, flying, avoiding things to fly into, find their prey, all within like a second, going on and keep on going. That's why if you see a bat flying around the night, they're not just flying like a bird, they're really kind of erratic. It's because they're eating and they just need to be like, oh, nope, my prey's over here, I need to avoid that. Bugs over here, I need to eat that. One survey we do is called a HARPNet. I only do this every now and then when I have like a grad student that's like, hey, I need a lot of fur from southeastern myotis. I'm doing a genetic analysis across their range, and I need 50 samples. So it's like, 50? Well, I'm not going to be able to catch that many bats in a mist net. But if we put them up on a node and roost, like a debris deflector, and then the bats get captured, they go into this bag, and then they just chill out onto this little roosting bar right here, and then we grab what we need, and they're just chilling right there, and let them go. So these bats actually, they started going back to sleep. They were chilling so much, they started going back to sleep. But it's pretty effective, but I only need it when I absolutely need it. Most of the time we're mist netting. I do this every year, whether it's tied to a specific project where I'm targeting species, or if I'm just in an area that we really don't know what bat species occur there. So this is put up at night. We open these nets up at sunset, and we usually go till midnight. Sometimes we close a little earlier if we're not catching anything. Sometimes we go a little later if we really are catching things and want to stay open. But we're looking for travel corridors. Bats usually fly high, so we need somewhere where they're flying low. So trails are great, creeks are great. And then this is a female eastern red bat, and she's just hanging out and we check their nets every 10, 15 minutes, and we pull them out, and we see what species they are, what gender they are. Like this female, was she pregnant, or was she lactating or post-lactating? Check the age, if it's adult or juvenile. Later in the summer, we start getting juveniles. In general health and standard measurements, and then we release them. So it really helps us figure out where bats are occurring, I promise you, at the end. And this is something we did at this summer, telemetry. It's widely used by a lot of biologists, and I really wanted to take a shot at it with bats. I know a lot about tricolor bats. This is a tricolor bat. I know a lot about them in the winter, but we really didn't know where they were in the summer. And with their potential being listed federally endangered, we really needed to know. So they made about 5% of our capture rates for mist netting throughout years of survey. So we really wanted to target them. So I told you I had a photo of you. That's Jack Creeley. That's my technician. I really couldn't do things without him. So I make him pose for photos. So this summer we were in Bienville and Tom Bigby. We really lived out in those national forests doing surveys. And we did catch our target species. We got 5 tricolor bats. We were only able to put transmitters on 3 of them. So these transmitters weigh 0.027 grams. And way it works with tagging wildlife, that has to be less than 5% of their body weight. So this bat weighs 4 to 6 grams, so I really need one that was 5.4 grams before I could put a transmitter on them. And the battery life on these is only 14 days, so you have to activate them in the field. So I'm there with a soldering iron, it's dark, and my eyes are a little bit better than Aaron's, and I'm like, yep, okay, it's connected. Okay, now we gotta seal it up, don't break the wires, glue it to the bat. Okay, so hopefully I can find you tomorrow. So we're tracking them during the day, and that's what he has right there. So these emit a beep, these pick up the beep, and then we follow the beep to find out where they're roosting. So this one, bat, we were fortunate, we caught it early in the night, and it turns out it was just roosting right nearby, so we didn't have to go too far. And it was in hardwood forests. It was really important to know that this species uses hardwood forest over pine forest, especially when we have a lot of pine plantations. So we were able to find her for 2 days, and then after that, never again. Because bats can fly very far, and the read range between this and this is about 1/10 of a mile. So you're walking around national forest, and you're really hoping you hear a beep, and you're searching. I was like, was that a beep? Nope. That was not a beep. But we were able to find her for 2 days. The other 2 bats we caught later in the night, and they were males, and I don't even know if they actually were roosting in the national forest or just come in and forage there at night. So we never picked them up, but we did get her. So that was really cool. Another project where we're monitoring individuals. We did this project for 3 years, and we're not doing it anymore. But we took there was this culvert. This is Louisville culvert. It's extensively long. It's I think over 2,000, maybe 3,000 feet long. It is huge. Most of the culverts, like short roads, about 100 feet. You get a double line that's up to 300 feet, so well over 1,000 feet. This is extraordinary culvert, and I've been surveying for years. And I broke it into sections, and because I've noticed walking in here that this area is a lot hotter and humid than this area, but there's less bats here and more bats here. So I wanted to know but there's still bats here, and there's still bats here where it's also hot and humid. I wanted to know what their preference was in the culvert, and if they were moving around in the culvert. And then there's culverts nearby that also has a lot of tricolor bats, and I want to know if the bats in this culvert were using those culverts and potentially spreading white nose. So we tagged a lot of bats. This culvert at peak numbers had over 2,000 bats. So when I say I tagged 298, it might seem a lot, but it's actually just a subset of what bats use in there. And we try to break it off in the sections, try to keep relatively even numbers, and then based off of females, so we had 127 females and 171 males. Turns out there was a lot more males in this culvert than females, so I got tired of it, like, oh, you're a boy, oh, you're a boy, but I'm looking for a girl. And eventually I was like, okay, fine, I'll just take you. But there's a pit tag, just like a microchip on a dog underneath their skin. It's that 10 millimeter, it's very tiny. And then they all have an individual band. So the bands you can't read unless you pick off the bat and you like have good light and you can read tiny little script on there. The pit tag, there's faults for both. Pit tags, turns out the bats can express them. So it can be a year after you tag them, and the bats will, the pit tag will actually come out of the bat. There's no external injury or whatnot, but somehow something that's underneath their skin and their back gets expressed out of their body. And it's something we've known. So I wanted a two-way method to know that individual without actually having to take them off and read them every time. So this is a scanner, and it picks up their individual ID. So then we were able to record that this one was in section A or section B. And it's a lot of data, and I'm still working on the results. But it was really cool to find out are kind of disappointing, actually. We had about a 20 to 30% recovery of our banned individuals. I was really expecting to be like above 80% with our recovery. I was really expecting that the same bats we tagged in here would be using it throughout the winter, but turns out it's not. So even though the numbers of bats keep increasing in each year and or pretty steadily, our marked individuals is actually going down. It tells me that even though I counted 2,026 as my highest number, there's probably actually over 3,000 bats that use this one culvert throughout the winter. So when they're not in the culvert, we did not find them in the other culverts nearby, but there's a national forest nearby, so they might be using the trees and then the culvert and back and forth. So that was pretty cool, and it really helped us with our population estimation of tricolor bats in the state. You know, we always just went off of our counts, but maybe we actually should be inflating that number, because that's just during the time of the survey. And I do have a lot of things to talk about bats, but I did try to limit it. So I will happily take your questions now.